Consider how the traditional remote access VPN solution works. A remote worker in the Midwest has to connect to a VPN concentrator in their headquarters located on the West Coast. Now, this remote worker is trying to access resources in AWS and can't go direct to that destination, so it's up to the headquarters to get that traffic to AWS on the East Coast. Now, this is a suboptimal traffic flow. This is going to add significant latency to that remote worker and lead to a poor quality of experience. So this is where the SD-WAN client is different. With the SD-WAN client solution, you can put client connectors in each of these locations. They function in some regard like a VPN concentrator, but where they differ from a VPN concentrator is they're responsible for advertising discrete resources. So if you look at the headquarters, the 1067 network is advertised by this client connector, and the 1068 in AWS is advertised by the client connector on the right. So the remote worker, in this case with the SD-WAN client, can go direct to headquarters and can also go direct to AWS on the East Coast, eliminating that hairpin, that backhaul that's going to lead to a poor quality of experience. So what does this look like to set up from the SD-WAN client orchestrator? Well, you're going to have various constructs that go into each of these network statements. You're going to have groups of users, groups of destinations, and you're going to combine those together with rules that govern what services users can and cannot access, as well as context that may restrict time of day access or geo-based access for that user. So here you see I have two network statements. One is users to headquarters, and more importantly to the right, you see my source are users, and also my destination is headquarters connectors. So all my client connectors that are associated with the headquarters have been put into a group. And if we look to the bottom, users to AWS US East 1 is my other network, and those users are associated with the destination for AWS US East 1 connectors. So this is how I'm articulating in the orchestrator how I want these networks to be formed. Now, starting with the remote worker, we can see what that experience looks like. So the first ping test that I ran was to the headquarters location, that 1067 network, and here we can see my latencies upwards to 121 milliseconds. So I'm behind satellite connection, so that's to be expected for what I'm using service-wise. And then if we look at the 1068 0.151 ping test going to the East Coast, that is a lower latency, averaging around 80 milliseconds. So this is indicating that this user is going direct to those resources. We can further validate this by bringing up the SD-WAN client app, and we can come over here to these options and look at the network connections. And so these network connections are going to appear from the user's perspective, going to those destinations, and it's going to highlight the networks that they're connected to. So these are the client connectors that I'm using to access resources. And as we see by this map, these are direct connections going from the user to that client connector, thus eliminating the hairpin and improving quality of experience. So I hope this video helps you to understand how a dynamic point-to-point remote access solution can, one, greatly improve quality of experience, and then in subsequent videos, we'll go into how this can also improve your security posture. So thank you for watching.